Today we are going to discuss the superposition theorem. So last meeting we discussed about the Maxwell's loop current, and another method to solve complex circuit is the superposition theorem. So what is superposition theorem? In a network of linear resistances containing more than one generator or source of EMF, example is the battery, the current will flow, or which flows at any point, is the sum of all the currents which would flow at that point if each generator were considered separately and all the other generators replaced for the time being by resistances equal to their internal resistances. So in superposition theorem, we have two sources, two batteries. What we do is we take first the first battery to supply all the currents in the resistances and get all the currents flowing in that resistance, and then we will take the second battery, same step, we will solve for the currents flowing in that resistances, and at the end we will superimpose the two currents combining at step 1 and step 2. Okay, so procedures of superposition theorem. So step 1, find the response in a particular branch by considering one independent source and eliminating the remaining independent sources present in the network. So we will short circuit the other source EMFs and we will consider only one source of EMF muna. And then another, no talo tay batteries mo. So mamintalo kamit nga ag-short. So mamintalo kamit pay nga ag-solve iti branch circuit currents. So repeat step 1 for all independent sources present in the network. Step 3, add all the responses in order to get the overall response in a particular branch when all independent sources are present in the network. So for this superposition theorem, we will have an example. Also, in a more complicated circuits, pwede kang gumamit ng two theorems. Example, no kaya't mausaran ni superposition theorem. But in the process nga in short mo ni source mo nga may isa, han mo nga ma-solve so na using simple series parallel. So you will use another theorem like Kirchhoff's and Maxwell. So we will take an example tamnon mas mag-gets yu tayo bagbaga. So simple pe lang example. Our first example is the first example in Kirchhoff's and Maxwell. So example, we have two batteries and EA and EB. EA has an internal resistance of 0.4 ohms. EB also has an internal resistance of 0.4. And these two batteries are connected to a resistance load which is 0.8 ohms. So solve the branch circuit currents using superposition's theorem. So I will assume the direction of currents for IA, IB, and IL. So this is my IA, IL, and IB. So kayo nang bahala kung anong gusto nyong direction of currents dito. Now, step 1 is We will take first the 24-volt battery and the other sources will be short-circuited. But, i-remain natin yung internal resistance. So, let's redraw our circuit using EA equal to 24 volts. So, ito yung magiging circuit natin. So, i-short natin si EB. We'll use the 24 volts. So, this is 0.4, 0.4, and 0.8. As you can see, we can solve this one using the series parallel circuit. Also, you can use Kirchhoff's and Maxwell. So, our RA now, we will name it as IA prime for A. For the first source. Again, we will assume direction of currents here. So, since this is the battery, it will supply the resistances. Kaya naging ganito yung directions. So, this is IL prime and IB prime. Our goal here is to solve for IA prime, IL prime, and IB prime. So, I will just use simple series parallel. So, solving for total resistance, RT is equal to 0.8 in parallel with 0.4, then in series with 0.4. So, you will get total resistance equal to 0.6667 ohms. You will now solve the IA because total current will be on branch current IA prime. So, total current is equal to IA prime equal to 24 divided by 0.667. So, that is equal to 36 amperes. We can now solve IL and IB using CDT. So, CDT for IL, it is equal to total current or your IA prime multiplied by R total divided by RL. So, this total resistance here is not the 0.667 but it is the parallel combination of 0.8 and 0.4. This one. So, IA is 36 times 0.8 in parallel with 0.4, that is 0.267 divided by RL is 0.8. So, IL is equal to 12 amperes. Using KCL, we can now solve for IB. So, current entering is equal to current leaving. So, IB prime is equal to IA minus IL prime. IA prime minus IL prime. So, 36 minus 12, that is equal to 24 amperes. So, nasolve na natin yung mga branch currents using 24 volts. And we are now ready to solve branch currents also using the second source voltage, which is 26 volts. So using 26 volts, we will redraw again the circuit. So this is your RA, 0.4, 0.8, 0.4, and the EB. Equal to 26. So this is 0.4 and 0.8. So i-short na natin yung EA. Direction of current. So for 26 volts, we will name our branch currents to be, this is IB double prime, IL double prime, and IA double prime. So solving for IA double prime, IL double prime, and IB double prime using 26 volts. So we will solve first the total resistance so that we can solve later the total current, which is the IB double prime. So total resistance is equal to the parallel combination of RA and RL, which is 0.4 and 0.8, plus in series with RB, which is 0.4. So that is equal to 0.667 ohms. Now, IB double prime is equal to the total voltage divided by the total resistance, equal to 39 amperes. Solving for IA double prime or IL double prime, we can use the CDT or the current divider theorem. So CDT, IL na lang. So IL double prime is equal to total current, which is IB double prime, multiplied by RT. Our RT here is not equal to the RT nga na-solve tayon. So this RT here is equal to the parallel combination of RA and RL divided by RL. So that is equal to 39 times RT is 0.2667 or 267 divided by RL is 0.8. So IL double prime is equal to 13 amperes. IA, using KCL equation, IA double prime is equal to IB minus IL. IB double prime minus IL is equal to IB 39 minus 13. So that is equal to 26 amperes. For our final answer, so this is our original circuit, and this was our circuit when we shorted the other EMFs. Also this one, so using EA and using 26 volts. These are the branch currents that we computed a while ago for EA and for EB. Now, how will we solve the final branch circuit currents of this electrical circuit using superposition? So remember this. Note, same direction with the reference is positive or addition. Opposite direction with respect to the reference is subtraction. So this is our reference, the original circuit. So our IA is going to the left, our IA prime is going to the right, and IA double prime is going to the left. So what will be the equation in that particular branch current? So IA is equal to same direction with the reference, IA double prime, and opposite direction with respect to our reference, so that is minus IA prime. For IB naman, IB is to the right, to the left, IB prime is to the right, IB double prime is to the left. So that is IB double prime minus IB prime. For IA, that is equal to IA double prime is 26 minus 36 equal to negative 10 amperes. IB double prime is 39 minus IB prime is 24. So that is 15 amperes. IL is equal to downward silang dalawa, IL prime and IL double prime. So ano? IL prime plus IL double prime. So that is 12 plus 13 equal to 25 amperes. Now, what is the meaning of this negative 10 amperes here? So, the negative here means that our assumed direction of current in the reference is wrong. So, etong IA dapat na to the left, ang corrected niya ay to the right. So, or 10 amperes to the right. We have another example. So, we have two sources, 120 and 105. So, this example is the same as our example in Maxwell and Kirchhoff's. We'll try to solve the branch currents I1, IA, I2, IB, and I3 using the Superposition'S theorem. First step is to short circuit our 105 volts and we will only use the 120 volts. Redrawing the circuit, we have here, we will solve the I1 prime, IA prime, I2 prime, IB prime, and I3 prime. So you can solve those branch currents using Kirchhoff's or Maxwell or the current series parallel method. I will use the series parallel method. For us to solve the I1 prime, we will solve first the total resistance of the circuit. So by doing that, we will first parallel the R3 and RB. So 6 times 1.5 divided by 6 plus 1.5 equal to 1.2 ohms. So after this parallel, we will series it with R2. So R2B is equal to 3 plus 1.2 is equal to 4.2 ohms. Next is the RAB23. So 4.2 multiplied by 21 divided by 4.2 plus 21 equal to 3.5 ohms. So RA 2B3 detoy. And then in our total resistance now will be R1 plus RA23B. So equal to 3.5 plus 1.5 equal to 5 ohms. Total current now, I1 prime is equal to 120 divided by 5 equals to 24 amperes. By current divider theorem, we can solve IA prime is equal to I1 prime multiplied by the total resistance. Here, the combination of R3B, 3B and RA, which is equal to 3.5 divided by RA, which is 21. So 24 times 3.5 divided by 21 is 4 amperes. By Kirchhoff's current law at this node, so I2 prime is equal to I1 prime minus IA prime. So 24 minus 4 is equal to 20 amperes. IB prime is equal to I2 prime multiplied by RB3. So 20 times 1.2 divided by 6 is 4 amperes. So by KCL, I3 prime is equal to I2 prime minus IB prime. So 20 minus 4 is equal to 16 amperes. So that's it for 120 volts. Let's go to 105 volts. So we short-circuited the EA or the voltage source A. I used again the series parallel method. You can try to solve this one using Maxwell. So, papadala ta amin the answers na. Before we solve the I3 double prime, these are the branch currents for 105 volts. I1 double prime, IA double prime, I2 double prime, IB double prime, and I3 double prime. Before solving the total current, which is the I3 double prime, we will solve first the total resistance. By doing that, we will first parallel R1 and RA. So that is equal to 1.5 times 21 divided by 1.5 plus 21 equal to 1.4 ohms. After that, we will series the R2. So that is R1 to A. 1.4 plus 3 is equal to 4.4 ohms. And then we will parallel again in resistance B. So 4.4 times 6 divided by 4.4 plus 6 equal to 2.538 ohms. The total resistance now is R123AB, 2.538 plus 1.5, that is equal to 4.038 ohms. Solving the total current, I3 prime is equal to the total voltage 105 divided by total resistance 4.038, that is approximately 26 amperes. By current divider theorem, we can solve IB double prime equal to I3 double prime times R12AB, combination of R12AB divided by the resistance RB. So that is approximately 11 amperes. I2 double prime by KCL at this node. So I2 double prime is equal to I3 double prime minus IB double prime. That is equal to 26 minus 11, 15 amperes. By CDT, IA double prime is equal to I2 double prime times R1A divided by RA. So that is equal to 1 ampere. I1 double prime by KCL, I2 double prime minus IA double prime is equal to 14 amperes. So, dito sa node na to. I2 double prime is equal to I1 double prime is equal to I2 double prime minus IA double prime. So for final answers, I1, branch current I1, I2, I3, and IA, and IB. So paano natin na-formulate itong mga equations na to? By the direction of their currents. So I1, our reference is our original circuit. It is going to the right, and I1 prime is going to the right. They are in the same direction, so kaya naging positive C. I1 prime. I1 double prime is the opposite, kaya naging negative. So I1 prime minus I1 double prime equal to 10 amperes. I2 is equal to I2 prime minus I2 double prime. That is 5 amperes. I3 is equal to I3 prime minus I3 double prime, negative 10 amperes. So, ang direction dapat ni I3 dito is to the left para maging positive 10 amperes. IA downward. So, IA prime and IA double prime are in downward also. Kaya nag-add sila. So, that is 5 amperes. IB also in downward. Downward, IB prime plus IB double prime is equal to 25. IB here is 4 pala. 4 to. So, 4 plus 11 is equal to 15 amperes. This is 15 amperes. So, kahit anong theorem yung gamitin mo, Kirchhoff's, Maxwell superposition, they are in the same, they have the equal final answers.